What is temperature? What are the three temperature scales? Temperature is a measure of the average kinetic energy of the individual particles of a substance. It's how much those particles are moving. Remember, kinetic energy is the energy of motion. So the more the particles are moving, the more energy they have, the higher the temperature is going to be. And to measure that temperature, we have three temperature scales: Fahrenheit, Celsius, and Kelvin. Kelvin you may never have heard of before. Fahrenheit, I know you've heard of because you know the weather and you know how warm or cold it's going to be outside. And Celsius you've heard of in science class. Now 0 Kelvin is absolute zero. That's the temperature where the individual particles contain no more energy. Everything stops moving. Remember our three states of matter? This is water as a liquid. This is water as a gas. And this is water as a solid. Notice the change in temperature. In the liquid we have 328 Kelvin. As a solid, 157 Kelvin, 0 Celsius. Let's cool it off even more. We're almost down to the impossible 0 Kelvin. Notice heat here even at 1 Kelvin. Now 0, there is no motion. Everything stopped moving. Here are the three temperature scales right next to each other, these little thermometers. Notice water boils at 100 degrees Celsius and it freezes at 0 Celsius. But on the Kelvin scale, it's at 373, water will boil at 273 before it freezes.
Here's a glass of hot water and a thermometer. This thermometer reads both Fahrenheit and Celsius. Fahrenheit on the left, Celsius on the right. Let's see what happens when we put it in the hot water. When we put the thermometer in hot water, the heat makes the alcohol in the thermometer expand, and the thermometer is calibrated such that it expands at a certain amount. We have the marks to tell us what the temperature is, the average kinetic energy is of the water. What is the temperature of the thermometer in Celsius?
What is thermal energy? Well, thermal energy is the total energy of all the particles. So if we measure up the energy of all the particles, it's that total energy, not the average, but the total. That's the thermal energy. And heat is the movement of that thermal energy from warmer objects to cooler ones. And that heat is transferred in three ways: convection, conduction, and radiation. Convection is movement that transfers heat by movement of currents within these particles. So they move around, and these particles are actually moving and they're transferring this heat. And when this happens, a lot of times we have the circular motion you'll see in diagrams. We have arrows going up and arrows going down, because this is caused by a change in density. It gets warmer, it becomes less dense, it rises, and then it cools off, and then it sinks again. We see this quite often all the time. We see it in the interior of the Earth, where we have these convection currents. The hot magma comes up, it cools, and then it sinks again. And the same thing happens when we have movements of air. It's called wind. The hot air rises, it cools, and then it sinks again. We have a convection current. Conduction is heat transferred from one particle to the next without the particles moving. So they'll bounce into each other, but they're not going to change place. They're not going to move around each other. So we see this when solids, like think a metal spoon in hot soup, will get hot, but those particles are not actually moving.
The metal pot is conducting heat. The heat from the flame down here is vibrating particles down at the bottom very quickly. And these particles are next to other particles to make them vibrate. And soon, the entire pot will heat up. This is why we need the thermal insulator on the handle. Otherwise, you could burn yourself from the heat being conducted through the metal. Metal, remember, is a good conductor. So this thermal conductor will heat our food, but we don't want it to burn us. So that's why we need the insulator. Conduction.
Radiation is a transfer of thermal energy by electromagnetic waves. This is how we get heat from the sun. That heat travels to us from the sun in the form of electromagnetic waves. That reaches us and heats the earth. Now here's a picture where we have all three working together. In this pot we have convection currents. So it's getting hot, cooling, and sinking again. We have radiation coming out from the fire, heating that pot, and conduction up the handle of the pot. It's getting hot. Watch out, dude, you're gonna get burnt. Look at that.